Well, modern Python testing, what does that mean? Well, it depends on the point of view. So for us from the Plone community, we're still stuck with all the old tests we have in Plone. And, well, we're writing tests, we are improving them, but we didn't have moved forward. While I was porting restricted Python to Python 3, I learned a lot that there are other frameworks, there are other tools, and what tools to use to make it more easy, more smooth to work with different versions of Python, different versions of the same framework, to test if that all are compatible. Yeah, that's what it is about. So, what is the goal of testing? To produce high quality and correct software like it is. But program testing can only be used to show the presence of bugs, not the absence. And that's the problem. You just can show that it works like you expected for your use cases, but there's always something that could happen, so never trust your own things. Try to test as much as possible, because then if something did not behave like you think, you have a way to start looking into it. Testing is about responsibility and sustainability. If you want to produce a product that works, that can be used over time, you need testing. And for us as Plone community, we are on the way to Python 3. So we do need something to test against different versions. So what is what you need to test? So I'm coming from a very, very bureaucratic background in the way of software development. So I was more than 10 years in the German Air Force doing software maintenance and software development for airplanes and helicopters. And there's a governmental standard that says how to write software. There are books about it. Ian Somerville and so on have written a lot about that. And there's a lot what you need to test. So if you start from the different sides, so normally in Germany the model is called V-model. It's also translated in the US and so on. So you have the user requirements. So it's on the very abstract level, and you go more and more into detail. But yeah, you need to test the corresponding parts. So it is about getting the things so that it works expected. So if you have a user requirement, you should have an acceptance test that shows that the software behaves exactly like that. And as smaller you go into detail, the smaller you should isolate your functionality and test if that works. And it is all about verification and validation that the things really are as expected. But, well, in open source software, we do have the problem. Who's noting the user requirements? Yes, we have requirements, but they are not formally written down in a requirement specification document or something like that, then given to the software architect who does a software design manual, a software design specification, and everything like that. So what we do have is an applied way of that. So our documentation reflects the requirements, the intentions. So if you do documentation first, you describe what you want to achieve, and you can already get people in discussing with you if it is the right way to do that or to get that things done. And test reflects the requirements. So test-driven development in open source is just fixing the requirements from the beginning, because you test against them. So writing tests is mandatory for good software. And testing leads to failure, and failure leads to understanding. You need to understand what you're doing. If you can do that, you can improve yourself and become better. And that's the thing I like about starting with that. Tests and everything are something special. We have some wordings, and I want to hope that we all have the same vocabulary and the same understanding of the words. So, what is a test? A test is a specific set of assertions. A test case is the smallest unit of testing. It checks for a specific response to a particular set of inputs. A test picture represents the preparation needed to perform one or more tests and any associated cleanup actions. A test suite is a collection of test cases, other test suites, or both. It is used to aggregate tests that should be executed together. What we do have in Plone are also test layers. A test layer represents the baseline for a specific test. So if we're looking to the model of the V or the test levels in the V model, we do have our unit test level, our integration test level, our functional test level layer, and that's where they're giving a baseline to. We do have something else, that is a test runner. That's a component which orchestrates the execution of tests and provides the outcome to the users. Because if we just run a test, like a normal Python code, it would just say method finished without any error or something. Okay, but there's no output. So if you want to collect, you get some more things done. The next thing is a test invocation tool. So the test invocation tool is a component which provides the required infrastructure to the test runner to execute the test set itself. And what we do also have are mocks. Mocks is to replace parts of your system under the test so that you can isolate the things and make assertion how something works without calling something larger. So it's about test isolation. So if we do writing tests, what to test? We need to test our requirements with the acceptance test, the design with the functional test, the interfaces with the integration test, the code with the unit test. So that's obvious for writing software, but we have two things else. We do normally have documentations, and as open source communities, we're writing developer documentations. There are code snippets in there that we show to new users. We should test them. They should work and run. That's important. And we do have conventions, coding conventions, things like import conventions, in which order they are grouped and so on, so that they're similar all over all packages. And you should also test them. So there are a lot of test frameworks in Python. I guess the most important to know is the UnitTest framework, which is in the Python standard library. It is used in Plone for testing, and it has some specific base classes, and there are different assert methods necessary to check if something works as expected. There are setup and teardown methods included in everything, and normal unit test can look like that. So that's from the Plone training documentation. So you normally have a class with a layer, then the setup and teardown method, and several test functions, and then you normally have something like a test suite collector or something like that. And you need specific assert methods. Well, why do you need something special for assert? Assert is a fixed statement in Python. So you can use that probably, or that could be better. And that's the thing that PyTest tries to achieve. PyTest is a framework to make it more easy to write simple tests. And that's also the thing that they complain about the name unit testing. It's about testing. It's not about unit testing. Unit tests are the smallest parts of testing, this baseline. But you can use unit testing for all of the levels. Because why not just call it test or Python test or something? And that's why they call themselves PyTest. And at the moment, for new frameworks or new libraries and packages in the Python world, that's the de facto standard. It makes some magic on collections and everything to make writing the tests simpler. And they just use the assert statement. So you can just use assert and compare the stuff. It does some magic or some code lookup to compare and give some better output on a failure, so that you can more easily look what's going wrong. It has an implicit test loader with it, and it has a pluggable add-on system, so you can have add-ons with PyTest that helps. And the PyTest we have used for restricted Python is just much more simpler. So you do not have any class anymore or something. You just have a method that either starts with test underscore or ends with test underscore. And those are found. You can annotate them. So for our example, we have tested directly against two implementations of restricted Python, the old one and the new one. So we pass the compile function or the execute eval function in that context as a parameter into the tests and test against two different implementations. And well, I said in my talk this morning, doing the impossible about porting restricted Python to Python 3. We have tests written for every possible statement in Python. So those are the things to just test the Boolean operators in Python. That could be that simple. So yeah, then we have some other frameworks. There's UnitTest 2, Nose 2. They are either forks of UnitTest or enhanced or backport functionalities. Nose was originally also a fork of the PyTest 0.something version. Today they're mostly outdated. The world has mostly moved to PyTest. So you should know that there exist, but can be used. There's another thing in the Plone world that is used a lot, that's Robot Framework. Robot Framework is a generic test automation framework for acceptance testing and acceptance test-driven development. It's the focus on web applications. It's a wrapper around Selenium to help you test the websites, how they would appear in a browser for the user. And a RoboTest can look like that. It's a bit larger, well, probably later look it up. It's also in the Plone training documentation from the code. It can check if you can log in into your site, can do click on specific buttons and so on and don't get any error. So if you're writing tests, the first principle is that you must not fool yourself. You're the easiest person to fool. So the problem always is you only test what you have specified directly. There are edge cases. The best examples are in other languages where there are direct limitations, for example, to the int or integer value. So you need to test the overflow and everything of that. If you don't test that, and there is some real world code that goes into it, it can happen that it fails. I think the Ariane 5 disaster was one of the examples, or others, where software in production failed and caused huge damage. So if you don't test it, you fool yourself. The next thing are test runners. We do have explicitly the UnitTest test runner, which collects and everything. Then there's the SOAP test runner, which adds test layer support so that you can specifically run tests against layers. The pytest test runner is the one that collects everything, the tests for pytest and so on, and execute it. The nice thing is you can use the pytest test runner on everything that is using just UnitTest. It works exactly the same. It understands the complete UnitTest framework and everything, just another test runner. It collects the same and gives even better output already. GoSap pytest layer is a translation of SOAP test runner, so the test layer support for pytest, so that you can use that and get some more. And it's all about orchestration. And if you orchestrate your tests, you can plug in other things. So you get the results, what you have tested, how many tests have run, in which time, with which coverage, and so on. So you can interact with other tools like coverage. That's also important to know how much of your code was actually tested. But you know, what does 100% of test coverage mean? Nothing. It really doesn't mean anything about the correctness of your code. In a scripting language like Python, it just means all of the statements of your code has once run, so you can ensure that it runs on the interpreter without giving a runtime error on starting up. But it doesn't say anything about correctness of your code. There's no direct connection between test coverage and functional correctness. Test invocation tools. We have three basics. One, you have command line invocation, or the command line itself. You have continuous integration servers, and in Python there's the TOX framework that I want to highlight especially, which is a local wrapper that does almost the same as you can do with continuous integration servers. So command line is the simple thing. If you have specified the test runner in your setup py, you can just say Python setup py test, and it runs all the tests. If not, you can do something like Python -m UnitTest test model and the test class to directly call your tests, or with pytest Python -m pytest and the directory where it should look up the tests. Or if you're doing build out like the Plone people, you have normally something like SOAP recite test runner in it. It generates the script test in the bin folder, execute it, and it runs all the Python, the Plone tests. So yeah, that's the thing basics. But, well, why? If you're doing tests, it should be as simple as possible. The people should use the code as simple as possible and test as often as possible. So continuous integration is a nice thing, because every time you check in your code into the repository and the continuous integration servers are connected to your repository, they check it out, run all the tests on it, and gives you a feedback if they pass or not. Yeah, that's fantastic. But the three we use in Plone are Travis CI, which are for Linux and Mac OS machines. It's perfect for pure Python tests. During the week where everybody's working, it's probably a bit slow. On the weekend, it's pretty fast. If you just use Python, then it's fine. If you do something especially where you need a database, some special setup also, so the things you do with Docker, Circle CI is probably easier to set up and maintain. It also provides you Linux and macOS machines. So if you need to test that, that's perfect. Up here is something special, and I think we should know about it, because we always claim that our software are operating system independent. Well, who of you really tests on Windows? If the software is running on Windows, who? Can I get a hand sign? One. Yeah, and that's the problem. So if we say all of our software also runs on Windows and no one tested it, it could happen that it does not work. And the one thing beside restricted Python I was working on in the last few months was Bob Templates Plone. So the skeleton tool to generate Python packages. The problem is it's currently not running on Windows due to the modification. So what we need is to test also all of those packages under Windows, and Appier just gives you that very easily. So if you're looking into a Travis CI example, it could be very easy. I later show something about Tox, but if you're using Tox with a continuous integration server, which in the first place seems like the most stupid idea you could have, because why you use a test invocation tool inside a test invocation tool to run tests, but you just have always the same invocation command for all of the different kinds of tests. So Travis CI, Circle CI, and so on have different tests, but the test invocation should be as simple as possible. And Tox just say, okay, just run this test environment. And that's perfect. So you can split all over again how many machines you need to make the test as fast as possible. And you should just say, okay, which versions you're testing, and then what you do. And you should not fool yourself. Continuous integration servers are sometimes losing all alone their connections. So if they can't install a package because the connection to PyPy was missing, it gives you a red flag without having done something wrong. Travis retry, for example, re-execute the same test 3 times to ensure that it is not bound to connection issues. So just a simple thing. Yeah. Test invocation tool Tox. Tox translates the concept of a continuous integration tool to local development. It is, in the Python world now, the de facto standard for local test invocation. So all you do in your base package root, just call Tox, and all of your tests are executed. So that's simple. That's something that everybody can learn or remember and do. It groups environments, so in some way it's very similar to the things we know from build out. And it allows us to test it against different Python versions, different framework versions, and everything. And there are some fantastic helpers outside. So if you have pyenv, you can have installed 20 different versions of Python on the same machine and just let them execute by Tox. It just does on every invocation, do a new virtual environment, install your product in there and run the test against that. And the easiest thing you can do on your machine is to create a Git hook. So for example, a pre-commit Git hook to test. If you want to try to check in your code, it runs the tests before. Nothing easier than that. So it's all about making it easier for you, giving high quality. And the Tox example can look like that. So you define an environment list of tests that always should be run. You can skip missing interpreter so that it fails when you're not having the interpreter and seeing the thing. Then you can have a set of commands and everything. In detail, it is a configuration, like everything. You can do a lot with it and pass. The nice thing is you can have more environments than that you're usually running. So there is the possibility to do some straightforward things like linter enforcement or something like that. So who of you uses isort? Okay. Who of you have or always reapply rules for something new? With Tox, you define something like an environment like isort apply, where all the command is in, and then you just can call tox -e isort apply, and the whole isort apply is done over your package. So you can have specific work done via tox for your package without the need that it is executed on every run. So for example, you can also do something with zest releaser to release a bug fix release of your version. We have that in restricted Python at the moment. And you can have larger snippets like that. So that's a linter subset, which is executed on Python 2.7 and 3.6. So we check if our syntax is correct on both sides. So it's all about getting back to the Zen development. The readability and everything counts. Get the user to do what they need to do, writing good software. And if you enforce your stuff, your coding conventions, everything, others are quicker in stepping up, contributing to your project, understanding it, reading it, and so on. And it's all about the thing that we also should do. Why do we need to maintain software that no one else than us is using just to run our tests? So like TestRunner. If there are better TestRunners out there, adopt them or use tools like that. So my wish is that we get to some new better practices for Plone to adopt Tox on all packages. Then we can test them against different versions of Python, different versions of Plone, so that we see if in the future, if we are on Python 3, something works with Plone 5, Plone 6, Plone 7, Python 3.4, 3.5, 3.6, and so on. And there's also another possibility. For pytest, the convention is that you do not place your tests within your source directory. There's also another thing with it. If you have in the base folder of your packages a source folder, a docs folder, and a tests folder, it gets a separations of concern, so the people quicker see where to look at. And the other thing is, if you're building binary distributions, wheels, pytest, X, or something like that, why you have to shift the tests with it? They won't be used at all. So in aviation software, the rule is never shift that code. Code that will never be executed should not be in the software. There was once another larger accident in the aviation while a debug statement was active in production code. Horrible. So that shouldn't be. And with that, we should enforce settings of our conventions, so editor.conf and setup.conf are things. I've started a project, Plone Best Practices Discussion, in the Plone repositories, where we can talk about the stuff we do in Plone, and there is a larger discussion or explanation on the lessons I have learned, and explanation what could probably be a good baseline for doing new test setups and setups of conventions within Plone packages. And I would like all of you who think about making new add-ons or maintaining add-ons to look at it. There might be a good way to enhance the development. And yeah, thank you.
Alex finished early, so we have plenty of time for questions.
All right, thanks for your talk. I wonder if you said at the end that okay, maybe we can throw away the tests on the final release, so don't ship the tests to PyPI. But then, yeah, at least in our current setup, then we cannot run those tests on the Jenkins server. Then, yeah, for Plone, you would need to check out every 300 packages or whatever to run all the tests combined. So for that would be trickier, or do you have another idea there?
Well, it depends. The one thing is that for a source distribution, I always think tests belong into there, but not for a binary distribution. So if we still release source distribution to PyP, they should contain the documentation and the tests. That's the one thing. For wheels, there's another thing. And the nice thing, if you're using something like pytest, you can have different folders for each of your level. The unit tests of each package should be tested within the package. If you have integration tests, acceptance tests, there where a lot of different packages work together, they could also be shifted with the tests in a different way. So you have also the possibility of the layers just by folders in some way and make it easier and smaller. Yeah.
More questions? I have a question. How hard would it be in an existing build-out to change to using docs? Because you need to have all the test path right?
The funny thing is, Mike Verstappen and me at the moment working on subcommands for Bob templates Plone, and there will be something that you can re-execute that on an existing packages, and it will drop you tox and everything in and run out of the box. So probably next year it will be a thing of 5 minutes to get your package toxified and then can test against that.
You couldn't just use the interactive interpreter and launch tox from that in a normal build-out?
I do it the other way around. So tox invoke build-out. So it just, you can already take everything from here. Here's are the snippets in for everything that would call build-out and do the tests for it. Because from build-out calling tox would be the wrong way around, in my point of view.
So any more questions? Then let's have an applause for Alex. And thank you.